Hybrid orbitals. The need for hybrid orbitals and why they exist. The issue is, once atoms bond, something else happens with their orbitals. And I understand that when we draw carbon, and you put 4 dots around it, what does that mean? Why do we put 4 dots around carbon? 4 what? Valence electrons. We have 4 valence electrons. All right? Well, that helps us understand how many valence electrons, but in reality, its orbital diagram from chapter 4 looks like this. Just to kind of remember what we're talking about here. Those 4 valence electrons, 2 of them are sitting in the 2s sphere, and 2 of them are sitting in dumbbell-shaped p orbitals. And while we sometimes depend on these things a lot, these orbital diagrams, or these Lewis dot diagrams, we need to sometimes remember what we're really talking about. Because 3-dimensionally, they're sitting in spheres and dumbbell-shaped p orbitals. So, and that's if you just have a plain Jane carbon atom. That's where they're sitting. But now let's bond them. And let's take those 4 electrons, these 4 electrons here, and let's bond them to something like hydrogens and make methane. When we make methane, we make 4 bonds with those 4 valence electrons to 4 hydrogens. And guess what? Every single one of those bonds is identical. It's not like we have the 2 S's form one type of bond and the 2 P's form a different type of bond. So there's got to be an explanation for that. And the explanation is, once bonding occurs, hybrid orbitals form. So, we're going to make a little chart here. Unbonded, and bonded. Yes, Mr. Henny.
I just got a joke for you guys. I came up with myself.
Mr. Henny has a joke he came up with himself. I'm recording right now, so I thought I'd include you in my recording.
This is embarrassing then. What does sulfur tetrafluoride love to do most?
Sulfur tetrafluoride, what does sulfur tetrafluoride love to do most? Yeah, they don't get that because it's AP chemistry. Seesaw. We don't talk about seesaws here. Write it down for AP chemistry though. Next spring it'll be hilarious. It'll be hilarious. You too. All right. So what we have with an unbonded carbon is there's one 2s orbital, and there's 3 2p orbitals. The bonded carbon forms, in this case, not always, in this case forms 1, 2, 3, 4 new orbitals to make these 4 bonds that are identical, and we call them sp3 hybrid orbital. It's a different shape. It has taken the s and the p's together, because that's where the valence electrons come from, and formed a new orbital called the hybrid orbital, and in this case the name of it would be called an sp3. What was the question, Mitch? Sorry. I'll show you why it's sp3. First thing to understand, though, is that we have 2 unbonded originally. 2s is lower energy than 2p, so I'm going up in energy here. And the new hybrid orbitals that are formed are somewhere in between the original 2. It's not like we have new higher energy electrons. It's just the combination of the 2. And now all these 4 valence electrons that have bonded to hydrogen that are in the sp3 orbitals now are all of the same energy. Because all four of those bonds are identical, they must be.